Hey, welcome to the last section of Chapter 2 of Trig. We're talking today about the law of cosines. It's the same idea as 2-6. We are finding missing sides and angles of non-right triangles. The difference with these is we are going to use them on triangles where we have three sides known, or we have two sides and the included angle known. So, and these are your formulas right here. These formulas will be given to you on the exam along with the law of sines, so you do not need to memorize these. If you need them, if you need to look at them, you can just Google law of cosines and they'll come up in your images. So problem 1, let's say we are given three sides. Side A is 68, B is 37, and C is 42. So you start by trying to choose one of these formulas that doesn't give you more than one unknown. Okay, if you plug in all your values and you have more than one unknown, you pick the wrong formula and you try another one. So I'm going to start by picking this top formula and plug in everything I know. Cosine of A. So again, the lowercase are the sides, the uppercase are the angles. So this is side A, this is side B, and this is side C. So I'm going to plug in 68 squared, 37 squared, 42 squared, 2 times 37 times 42 times the cosine of A. So I plugged in everything I know, and I only have one unknown right here, which is what I'm going to solve for, so I'm in business. The most common error in these problems is people combine all of these numbers together. That is incorrect because that is a violation of the order of operations. You cannot split this multiplication off for sake of the addition and subtraction. Those go in a different order. So please pay attention to how I'm simplifying as we go through this and be careful what you do. So I'm squaring everything. So 68 squared, 37 squared, 42 squared, and then I'm going to multiply these three numbers together. 2 times 37 times 42 is 3108 cosine of A. The next thing I'm going to do is combine these two because they combine in addition. I am not going to subtract the 3108. That would be a violation of the order of operations. So all I'm doing is adding the first two numbers, and I'm getting 3133. And now I'm going to solve this by isolating cosine of A. So I'm going to start by subtracting 3133 from both sides. And I get 1491. And then I'm going to divide by 3108. And I'm going to get negative 0.4797. Please do not round this number. Use inverse answer if you're going to recalculate with this number, or store it, please. So now to get A by itself, I'm going to do the inverse cosine of both sides. So that I'm finding an angle, and just make sure you're in degrees when you do this. Inverse cosine of the answer gives me 118.67. That's going to be my angle A. Okay? Then you do the problem again for a different angle. So I'm going to use a different formula this time. use the second one so I can find b. So b is 37 squared. A is going to be 68 squared. 42 squared. 68, 42 cosine of b. And the algebra looks the same. I'm going to go 37 squared. 68 squared. 42 squared. 2 times 68 times 42. 4624 plus 1764 is going to give us 6388. And now I'm going to subtract. Divide. And then do the inverse cosine of both sides. And I get 28.52. Now, once you find two of your angles, you can just simply subtract from 180 for the last one. 180 minus 118.67 minus 28.57. This is going to be what angle C is. I get 32.81. So that's my last guy. Now, what happens if you end up subtracting at the end here and this number is negative? Anybody know? That means that this triangle does not exist, and that happens sometimes. Or sometimes when you do inverse cosine of an angle, you get an error in your calculator. That means that the triangle doesn't exist also. So be aware that that does happen from time to time. Now, interesting little thing to ponder. In the law of sines, sometimes we had more than one answer. And we talked about this in the last lecture. The reason is because when you are looking at the sine, which is a y-coordinate, this is where your sine x value is, there are always two answers. This is your y component right here, but there's also another y component over here that is always the same. This distance right here matches this distance. And so this coordinate also has the same y value. And because the y values are positive and positive here, they match exactly, which means that when your calculator gives you, say, 10 degrees right here, that means that you also could have 170 degrees, reference angle of 10. What happens with the cosine, though, when you're doing the inverse cosine, there's always two answers when you do an inverse function, okay? But let's look at where those are. With a cosine, here's a point right here, and now my cosine is my x value. Where is the place that has that same x value. We're looking at x components here, this distance. Well, that's happening in quadrant 4. You're going to have the same x component here on this coordinate. If you look on your unit circle, you'll see that that's true. For cosine, quadrant 1 and 4 match. Here's the issue though. Say this is 10 degrees right here. Then that means that this angle right here is 350 degrees, okay, with a reference angle of 10. Well, there isn't a triangle that has an angle of 350. The maximum total angles in a triangle are 180. So when you're using the law of cosines, you don't have duplicate options for answers. You do have duplicate answers, but this one in quadrant 4 is always going to not work for a triangle. So that's the advantage. The formulas are a little more complicated, but you don't ever have to deal with the double triangle situation. So for me, I always prefer to try to get law of cosines to work first, because then I don't have to worry about anything. And then if I have to go over to law of sines, then I'm looking for that second triangle always. Now I just did one example. I think this is going to be fairly straightforward. It's possible that I can give you any component of these. Like I could give you side A. Actually, let's do one of those. I'll show you what those look like. Let's do one more example. I'll move this guy down. And let's say that angle A is 88, side B is 8, and side C is 2. So ABC, A is 88, B is 8, C is 2. So again, this is a side angle side situation. So this works. Now, which formula do you use? Well, I'm going to try one. Okay, I'm going to take this. Let's slide these down here so we can look at them. I'm going to try the first one, and we'll see what happens. Okay, you've got a squared. Well, I don't know a squared. Okay, so that's just a squared. B squared is 8. C squared is 2 squared minus 2 times B times C cosine of 88. Yay, that worked because I only have one unknown. If you pick one that has more than one unknown, then you've picked the wrong one and try something else. Okay? And so, for example, say you had picked this one right here. This is what it would look like. C squared is 2 squared. A squared, I don't know. B squared is 8 squared minus 2ab cosine of C. Well, look what happened here. I've got an unknown A here, and a C. That's not going to work. I've got too many unknowns. So that's how I know that's not the formula to use. That's what it would look like. Okay. So in this situation, I just crank this all out. Now, your calculator does understand order of operations. So if you just type this in exactly like you see it, you'll be good to go. And we're not doing inverse cosine, we're just doing straightforward cosine. I get that a squared equals 66.88. So if I want to solve for a, I'm going to square root both sides. So that makes a plus or minus, but minus doesn't make sense in our context. So this is 8.178, and that's going to be side A. Now I need to find an angle. So I need to use a different formula. with one of the angles I don't know, so I'll try this second one, see what happens. I've got a b squared, I'll just plug it in. B squared is 8 squared equals a squared. I'm storing this in my calculator as a in my class calc or as x in my TI, so that I can use that instead of this rounded number. Otherwise you're going to have a lot of error. C squared is 2 a c times the cosine of b. Alright, let's go through this. 8 squared is 64. Now I'm doing my stored number squared. That's going to be 66.88. Okay. 2 squared is 4 minus 2 times my stored number times 2, and I get 32.713 cosine b. Okay, subtract your things over, so 64 minus 4 by and I get cosine of b equals negative 0.210. I do inverse cosine of both sides, and I get 102.15. That's going to be my angle B. Then you can subtract from 180. To get angle C. Now, look at what happens when you do this. I go 180, that's my total triangle, minus the angle B, minus angle A, this is A, this is B, and that's how I'm going to find angle C. Here's what I get. Wah, wah. Okay, can't have a negative side. That means that this does not exist. And that is what's going to happen. If anything bad like that goes wrong, that means that this triangle doesn't actually work. Okay, try some of those problems and